Dealing with noise is often the biggest hurdle in amateur radio, especially on the lower bands where the noise floor is notoriously high. Effective noise reduction isn't a single magic button on your radio. It is a system-wide approach that starts before the signal even reaches your antenna. Stop local QRM at the source. The absolute best noise reduction happens before the noise is even generated. Man-made noise from household electronics often completely masks natural atmospheric noise. Switch off the main electrical breaker to your house and run your transceiver on a battery. If the noise flow drops significantly, the culprit is inside your home. Switching power supplies like those powering single-board computers or routers, LED lighting ballasts, flat-screen televisions, and variable-speed motor drives are the common offenders. Replace noisy switching power supplies with heavy linear power supplies where possible. For appliances you can't replace, wind their AC power cords through heavy ferrite toroids to choke the RF noise before it radiates. Block common mode currents. If your antenna feed line runs near noisy household electronics, the outside shield of the coaxial cable acts as an extension of the antenna, bringing that local noise directly into your receiver. Place a 1:1 current balun or heavy ferrite choke at the feed point of your antenna. This is particularly critical for wire dipoles to prevent the coax shield from radiating or receiving. Place another choke on the coax right before it enters your radio equipment. Not all ferrites are equal. For lower frequency HF bands like 80 meter and 160 meter, Mix 31 or Mix 73 ferrites offer the correct impedance to suppress common mode noise effectively. Utilize dedicated receive antennas. A resonant transmit antenna is great at getting your signal out, but it also picks up every bit of static for miles around. Separating your transmit and receive paths is a massive advantage on noisy bands. Magnetic loops. A small shielded magnetic loop antenna responds to magnetic field rather than the electrical field, where most of local household QRM lives. Because loops are highly directional, you can physically rotate them to place at a local noise source into the antenna's deep null, effectively erasing the interference. Beverage antennas. If you have the acreage, a long wire laid low to the ground offers incredible directivity and staggeringly low noise flow, allowing you to hear weak signals that would be buried on a standard dipole. Ensure strict station bonding. RF grounding is entirely different from electrical safety grounding, and getting it wrong creates a breeding ground for noise. Equipotential bonding. Every piece of equipment in your shack, transceivers, linear amplifiers, SDR boards, and power supplies should be bonded together using wide copper strap which has lower RF impedance than braided wire to a single common ground bus. Preventing ground loops. Poor grounding in setups that utilize interconnected digital boards, microprocessors, and amplifiers allows digital clock noise to creep directly into your RF signal chain. Receiver side digital signal processing and filtering. Once the signal and the noise is inside your radio, you have hardware and software tools to clean it up. Modern software-defined radios excel at this stage. Hardware filtering. Proper front-end low-pass and band-pass filters prevent strong out-of-band commercial signals from overloading your receiver and artificially raising the noise flow. Noise blanker. Designed specifically to chop out sharp, repetitive pulse noise such as electric cattle fences, automotive ignitions, or sparking power lines. It works by briefly muting the receiver during the millisecond the pulse occurs. Noise reduction uses complex digital signal processing algorithms to identify random steady white noise and mathematically subtract it from the audio, pulling the human voice or CW tone out of the static.